Welcome to our second lesson of chapter 6. We are going to continue looking at some new identities today. Last day, we reviewed our reciprocal identities and our quotient identities. And then we also looked at a new identity, which was Pythagorean identity. That identity is probably going to be the most common one you will see. Today, we're going to look at three new types of identities: sum, difference, and double angle identities. Again, these are all on your formula sheet, which is posted in the chapter 6 folder. You will need that for these identities, or you will need to have these notes out. I don't even have these memorized. I think the only one on this page I have memorized would be the double angle identities, but you'll notice the sum identities all look very similar, and it is a little bit hard to keep them straight. So even when I'm dealing with sum and difference identities, I pull out my formula sheet and take a look. I don't memorize these. I don't use them enough to need to memorize them. So one thing about your sum and difference identity is please note that you cannot distribute the sine or the cosine into the brackets. Sine or cosine are not variables. You cannot distribute them in. They are not numbers. You cannot distribute them in. Okay? So you cannot do this. This does not work. Not true. Doesn't work. Don't do this. If you see a sine with brackets or a cosine with brackets and stuff inside, take a look at your formula sheet, look at your identities, okay? You cannot distribute. Sine and cosine are functions, not numbers. You cannot do this, okay? So we're going to take a look at some different ways to answer questions using these identities. One of the ways of finding these helpful is if you're being asked to evaluate things that do not have special angles. Sometimes there's a way you can rewrite them so that you can express the angle given as a sum or a difference of two special angles. Other times it's just to simplify a function that looks disgusting, and we can make it look a little less disgusting. So when you are doing these questions, you need to have that formula sheet sitting in front of you, and basically you're taking a look and saying, what does this look like? Okay, so if I look at these two questions here, if I look at 1A, I've got sine of something, cosine of something, minus cosine of that same first thing I had and sine of that same first thing I had. So if I call this first one A, this looks like I have sine of some angle A, cosine of a different angle, I'm going to call it B, minus cosine of that same first angle I had, which we called A. And then I have sine of a different angle, which was the same as the second angle, B. And so if I take a look at all these identities, the question is, what does it look like? Well, it kind of looks like this one right here. Okay, so that means that this is equal to sine of A minus B. That's my identity I have right there. Now, in my question, I didn't have A's and B's. I had 48 and 17. So that means that this is equal to sine. My A was 48. That's where I have my A there, is where the 48 is. And the B is 17. Now, I can subtract 48 and 17 and get 31. Okay. We express this as a single trig function. We've answered the question. If it asked us to evaluate, we would plug this into our calculator, making sure our calculator's in degrees mode, but it hasn't asked us to do that, and we're going to stop there. Now, the second question, same thing. If I take a look, this looks like cosine squared of some angle A minus sine squared of that same angle A. And if I take a look above, what does it look like? Well, it kind of looks like this right here, which is equal to cosine 2A. Again, we don't have an A in our question. A was pi over 6. So we're going to rewrite this as cosine 2 pi over 6. Now I can simplify that fraction. The 2 and the pi over 6 are both inside the cosine. They're both part of the angle there. So we're going to rewrite this. If I simplify that fraction, I get pi over 3, which also happens to be a special angle. But we were not asked to evaluate. We were just asked to write as a single trig function. So we're done. So obviously, I can't do this if I don't have my formula sheet, unless I have them all memorized, which I don't. So I need to literally look at my sheet and say, which one of these does this look like? Okay. The stuff in red, you might not need, you might just look at the formula sheet and be able to see it. Some people can just tell and they're like, oh, there it is. 48 is my A, 17 is my B, I'm done. I need to look at the sheet and say, okay, really analyze what does this look like? Am I adding or subtracting? Do I have two signs in the first term? Like these two where the two signs are together and the two cosines are together? Or do I have a sine and a cosine paired up separately? So am I looking at a sine or a cosine sum or difference? Which is it? Is it a sum or is it a difference? Taking a look at the term in the middle. Okay. So it does take a little bit of practice to notice what you're dealing with, but you do need your sheet. You need these identities handy, or it's going to be difficult to do. Okay. Now you'll notice that for cosine 2a, there were a bunch of options, and our options were cosine squared a minus sine squared a, 2 cosine squared a minus 1, or 1 minus 2 sine squared a. We had 3 options, so there wasn't just one. And because there are 3 options, this is what tends to mess people up a little bit, because when they are doing simplifying questions, they don't know which one to pick. So this question is simply saying, determine an identity, well, these are our 3 identities, that contains only the cosine ratio. So the question is, which one contains only the cosine ratio? Well, this one. The other ones both have a sine squared in them. So this one is the only one we can choose that does not have a sine in it. Okay. For number 3, it's asking us to find one that contains only the sine ratio. Well, that would be this one. The other 2 both have cosines. Okay. So being able to pick those out will come in handy for your simplifying questions. Again, any of the simplifying questions, it actually doesn't matter which one I pick, but it will determine how much work we need to do. So if we pick the quote unquote wrong one, it's not actually wrong. It just might mean you've got a lot more work on your hands than maybe was necessary. So let's try some. So if it says simplify, my first thing is I want to change everything to sine or cosine. Okay, and this one gives me a hint. It's one of the 3 primary trig functions that this is going to equal when we're done. So it should equal sine, cosine, or tangent. Okay, it gives you a bit of a hint as to what we're supposed to equal. Now, some of you might look at this and go, well, it already is sines and cosines, but it's not. It's a cosine 2x and a sine 2x. Okay, when I say change to sines and cosines, that means just a cosine x or a sine x. They can be squared, that's fine, but there shouldn't be something else inside the function like a 2. So the first thing I'm going to change is the bottom, because the bottom, we only have one option. Okay, we don't have multiple choices. The identity on the top, we have 3 options. So I'm going to change the bottom first, just because I know exactly what it should equal. And the bottom, the identity from your formula sheet for sine 2x is 2 sine x cosine x. Okay. Now we know that things are going to have to cancel out, and they're going to have to equal by the time we're done sine, cosine, or tangent, because it told us that in the question. So the question we have is, well, which identity should we pick for cosine 2x? And the answer is, it doesn't matter, but I do know that they won't all result in the same amount of work. So in my notes online, I used the 2 cos squared minus 1. In these set, I'm going to use the 1 minus 2 sine squared x. And the reason I'm picking that is because I know that if things are going to cancel out from the top and the bottom, that 1 on the top here, this is a problem. We need to get rid of that. We need that to go away. And how can I make that go away if I'm subtracting cosine 2x? So if I take a look at my options for cosine 2x, I'm going to write them here just because we can't see everything at the same time. We have this guy. We have this one, and we have this one. Okay, so I know that if I want to get rid of the 1, I should probably pick one of the top 2. I don't want that last one because it can't get rid of the 1. So one of the other ones are what I'm going to probably want to pick. Now, if I'm doing on the top 1 minus this stuff, which of these, when I do 1 minus this, will actually get rid of the 1? Well, the top option. So if you want to see what the math looks like if I had chosen the middle option, again, the PDF answer key that's posted online has the middle option chosen instead. So you can see how much extra work that would be, but that it will still work and we'll get the same answer. I'm choosing the top one, the 1 minus 2 sine squared x, because when I distribute the brackets, now I get 1 minus 1 plus 2 sine squared x all over 2 sine x cosine x. And the ones cancel out right away. If I didn't choose this one, again, it would still work. It would just be more work. Okay, so now I'm going to rewrite this. And we see that we've got a 2 on the top and the bottom. Those cancel. We have a sine x on the top and the bottom. So sine x from the bottom will cancel with one of the ones from the top, leaving me with just a sine x on top and a cosine x on the bottom. And this is equal to tan x. So this was not a lot of work. This was 1, 2, 3, 4, 5 steps, but I could have made it less because I showed every possible step. If I chose the 2 cos squared x minus 1 option, the middle option for my cos 2x identity, if I had chosen this one here, I'm counting on my online answer key 1, 2, 3, 4, 5, 6, 7, 8 steps. So extra work, but I will result in the same answer. Okay. All right, so we're going to do 2 more questions. These ones are asking us to find an exact value for each expression. Now remember, exact value means you're not putting it into your calculator. We need to use special triangles. So just a reminder, we had 2 special triangles. Our special triangles were our 1, 1, root 2 triangle with pi over 4 in the corners, or 45 degrees. And our other one was 30, 60, 90, or pi over 6, pi over 3, where we had 1 across from the pi over 6, root 3 across from the pi over 3, and 2 is our hypotenuse. Pi over 3 is 60 degrees. Pi over 6 is 30 degrees. Okay. Now, the problem we have when we look at this is we're being asked to find an exact value of sine pi over 12. Pi over 12 is not a special angle. Pi over 4 is a special angle. Pi over 6, pi over 3, those are special angles, but not pi over 12. But yet we've been asked for an exact value, which tells us we should be able to make pi over 12 using special angles somehow. So the question is, since this is not a special angle, can we make pi over 12 by adding or subtracting or doubling special angles? Okay, so our three new identities were adding, subtracting, or doubling. Sum, difference, and double angle identities. So the question is there any way we can make pi over 12 from our special angles by adding two of them together, subtracting two of them, or doubling one of them? And then we could rewrite this sign of pi over 12 using one of those identities. So our angles were pi over 3, which is the same as 4 pi over 12, pi over 6, which is the same as 2 pi over 12, pi over 4, which is the same as 3 pi over 12. Okay. So if I take a look at these, the reason I'm using pi over 12s here is because the question says pi over 12. If it was over 15, I would have put these all over 15. Okay. So I can either subtract these two. Okay. Or I could subtract these two. Because 4 pi over 12 minus 3 pi over 12 would give me pi over 12, or 3 pi over 12 minus 2 pi over 12 would give me pi over 12. So what that means is there are two solutions to the question. So again, I've shown one of those solutions in the PDF answer key online. I've used the ones in red here, the 4 pi over 12 and the 3 pi over 12. I've shown that version online. So I'm going to do the other version here. Okay. So if I do the ones in black, the 3 pi over 12 and 2 pi over 12, this means I can rewrite this as 3 pi over 12 minus 2 pi over 12, right? Because pi over 12 and that stuff in the brackets are equal. Now I'm going to rewrite these again so that these are my special angles. And then I can use my double angle identity to expand this. Okay. So, or sorry, not my double angle identity, my sum difference identity. Okay. So if I take a look back at my difference identity at the top here, my difference identity, now that this is a giant mess, let's fix this up and make this a little bit nicer. Because we're going to be referencing this again. I'm looking at this one here with the star. So I've got two angles inside that are subtracting. That's what I've got. So I'm going to expand it like this here to the right. Okay. Okay. So this is looking like sine of A minus B, which is sine A cosine B minus cosine A sine B. So for us, A is pi over 4 and B is pi over 6. So I'm going to expand this out. This is then going to be sine of pi over 4 cosine of pi over 6 minus cosine of pi over 4 sine of pi over 6. So I need to know what these equal. So just a reminder, again, my triangles are up top, but I'm going to just draw them again so I don't have to scroll over and over. Okay, so if I take a look at my triangles, sine of pi over 4 is equal to 1 over root 2. Cosine of pi over 6 adjacent over hypotenuse is root 3 over 2. Cosine of pi over 4 is also 1 over root 2. Sine of pi over 6 is opposite over hypotenuse. That's 1 over 2. And now if I multiply these together, I get root 3 over 2 root 2 minus 1 over 2 root 2. And we're going to just rewrite this as one fraction because they have the same denominator. We'll write it like this. And we can leave it like that. It's that exact value. We do not want to plug this into our calculator. We want to leave it. We could also rationalize the denominator if we want, but leaving it like this is fine. We're going to try one more, but with degrees. So again, our special values, this is not a special angle. But can we rewrite this? By adding, subtracting, or doubling special angles. Okay. And so our special angles, again, are 30 degrees, 60 degrees, 45 degrees. We could also include 90 degrees, 180, 360, etc., or any other iteration of these special angles that are in other quadrants. These are all in quadrant 1. We would have other ones in other quadrants, but if we take a look, is there any way we can add, subtract, or double any of these to get 105 degrees? And the answer is yes, these two. If I add these two, it equals 105 degrees. Now, I don't have the tangent double angle formulas written on our notes here, but they are on our formula sheet. So I'm just trying to get my formula sheet up here. Where did it go? I lost it. There it is. So here's our formula sheet. And we decided to add those two together so we can see that that is right here. Okay. So I'm going to rewrite this on my notes here so that I can see it. So since this is tan of A plus B, tan of A plus B is tan A plus tan B all over 1 minus tan A tan B. And for us, A is either 60 or 45, it doesn't matter, and B is the other one. Okay, now let's rewrite it. So we've got tan 105 is equal to tan 60 plus tan 45 all over 1 minus tan 60 tan 45. Now again, we need our special triangles. This time I'm going to draw them with degrees. And then we're going to replace all of our tans with actual numbers. So tan 60, if I look at my triangle, is opposite over adjacent. So this would be root 3 over 1. You don't need the over 1. Tan 45 is 1 over 1, which is 1. Then you end up with 1 minus tan 60, again, is root 3. Tan 45 is 1. And then I'm just going to rewrite this neatly so that I don't have all these brackets floating around. Root 3 plus 1 over 1 minus root 3. And again, we can leave it like that. You could rationalize the denominator by multiplying by the conjugate if you wanted to, but you don't have to. It's an option here, but you can just leave it like this. Again, it's that exact value, so we do not want to plug this into a calculator. We would leave it with the radicals with the fraction. Okay, so again, it's a little bit hard to do these questions if you don't have that formula sheet handy or you don't have the formulas from the top of your notes handy. Again, the tangent ones, you won't use these ones very often. They come up every once in a while, but I don't have those memorized. You don't use them enough to have them memorized, but you will see them again when you take further math, if you take further math. Okay, and that's all for today.